In raster analysis, zonal functions are one where you input a layer and then zones, which are based on a different layer, are the basis on which the input layer is evaluated. In this example here, we can see that we have an input layer. The zone layer has either values of A, B, and C, and maybe we can see that better if we just kind of outline where those boundaries are there. And then we can see that if we take all those grid cells from the in layer, for example, in the orange area, A, and we average those, we're going to get a value of 2.7. That value is what's put into the output layer in all of the grid cells that are covered by the area, the zone A, from the zonal layer. In the same way, in zone B, the average is 6.6, and in zone C, which includes that one isolated grid cell, otherwise surrounded by zones A and B, the average is 9.2. So those are all of the values assigned to the output layer. One way that we can use zonal functions is if we have some sort of land use or land classification, and we want to see how much of it is occurring within different administrative units. In this example here, we're simply summarizing within each of these counties how many of the grid cells fell into these different categories, such as water, developed, forest, etc. And that way we can kind of summarize the entire land classification here based on what these, based on how much of each occurs in these counties. So this is kind of a nominal example where each of the grid cells would have a category or classification associated with it. But we can also do it if we have scalar values or numeric values associated with it. This is an example here where we're going to use these as the zones. These are the fifth code hydrologic units for the state of Montana. And we can see all of these outlines here sort of form a natural but irregular grid across the state. If we have a raster data set that we want to summarize within those zones, such as the slope, we can see that this shows the slope map for Montana based on a 30-meter grid cell, and we can see a whole lot of detail here. We can then use a zonal raster analysis in order to summarize all of those slopes within the watersheds, within those watershed boundaries. And this might be something useful if we were looking for total maximum daily load, where we might be more likely to find mass wasting occurring and putting material into the rivers and streams through these areas. And here we're able to get this sort of example where we've taken, once again, an average of all of the slopes of those from those grid cell values, and we've summarized that within these zones, which are the fifth code watersheds.